That's yeah, and that's live. So I call it a false start. So I just learned that I forgot to click unmute. How cool is that? But yeah, thanks, folks, for letting me in, because I was just I started speaking about the way how I'm gonna run this live stream, so that I'm gonna from time to time read your comments, and then I took a look on your comments. So thanks a lot for letting me know about how brilliant I am. So short break. So before I repeat again what I said, just hi, folks, the ones that are already here. Thanks for joining. So again, but this time it's going to be maybe quicker. So I just wanted to make some intro. So I'm Lukasz Górnicki. I'm one of the maintainers at AsyncAPI initiative. And over the last couple of weeks, I was refreshing my knowledge about the WebSocket to see what's the direction of the protocol at the moment. And of course, I was exploring how it can be used within the Async API specification, because recently, not only recently actually, over the last couple of months, many people come and ask for some examples about how to describe a WebSocket API with Async API. So the goal here is to actually repeat what I already wrote in 2 blog posts. Why repeat? Because I notice, even after my looking at my own experience, many people don't have time to read. I don't have time to read. I have many blog posts open in tabs in the browser that I've never had time to read, unfortunately. But it's affecting the learning capabilities. So the plan here is that I want to, as often as possible, to provide a podcast, a recording, or just a YouTube video that explains some subject that I described in the blog post. So you don't have to spend like 20, 30 minutes on like just focusing on the content of the blog post, but instead you can actually prepare a dinner in the kitchen and at the same time listen to the recording. I hope it makes sense for you. We'll see. Basically, I'm exploring the topic, so let's see. The way I'm gonna run this live stream is that basically this live stream is for you. It's not for me to show off. It's for you, so you can learn during the live stream. Otherwise, I could just record it, this video, and just release it directly to YouTube. But the plan is to do it live stream, because if somebody is actually here with me at the moment and I'm explaining something that is unclear, just feel free to drop your questions in the chat, and I'm just gonna stop and try to explain something in a different way. So I hope that's clear. I'm gonna because I'm gonna watch one screen only. So on my mobile, I'm gonna open the Slack, because I turned off Slack. I turned off Slack, so there are no notifications showing up and I'm not being disturbed. But if there's something important, like for example, I see that on our AsyncAPI Slack, many people also ask me, like, let me know that the recording is off, the voice recording is off. So that's, I think, a good reason to have the Slack opened. Looks good to me. Let me now share the screen. Okay. I know the screen is small, but just can someone confirm in chat that you can see it? At least on my side, it looks good. Yeah. That's so that I'm gonna increase it. I just wanted to make sure that the screen sharing works. So that's the playground. But yeah, let's first actually go to the article, to those articles that I mentioned at the beginning. So I'm gonna paste links to those. So it's this one. It's a first like introduction into the topic. And this is the other one where I in details describe how to create a async API document for WebSocket. So I'm gonna basically combine those two and add something extra. What I've learned even after publishing the blog post. There's also a third blog post. So feel free to share your opinions if you want. I'm gonna paste the link as well. So a third blog post, which is the last blog post about WebSocket. This one is purely about code generation. It's something that I'm not gonna talk about today. And if you're asking a question like when will be the session about code generation for WebSocket, I didn't plan one because I recorded a presentation I'm gonna present on where is it? So there's a conference. Oh yeah, there is a conference, Event-Driven Architecture Summit. I think it's a first time it's gonna happen, and it's gonna happen soon, 19th of May. So it's almost less than 2 weeks. And the agenda is not yet available, but yeah, I'm gonna make a session about Async API and WebSocket, but from the point of view of like Async API as a tool that you can use to design your API first and then generate code, and then continue working with your features and solution. But as I said, that's already recorded. It's going to be released on the day of the conference. That's why I didn't plan any live streaming about it. But if after watching the recording from the conference you think it's something needed, then yeah, feel free to let me know. I can set up something. Okay, let me check chats. Okay, so the meet 14 minutes after starting the stream. Sorry for that. So the like if you don't know yet, so let me tell first the story maybe of WebSocket. So it's pretty, from my perspective at least, it's pretty old protocol, as it was introduced in 2011. I mean standardized. 2011, it's 10 years ago. quite a lot. The first time I've learned about it was 7 years ago, when I was working at SAP, and we were doing a a kind of SaaS solution where you had we had like over 160, I think, different APIs. So it was you had a marketplace of APIs. You could build front store or any different things just by subscribing to those APIs and using them. And we were, of course, we always wanted to do there some innovative stuff, and we also wanted to have like nice UIs where you can provide a nice experience to the users, so they don't have to see updates in the UI. They don't have to refresh the browser all the time. But we wanted to provide a kind of nice experience that the UI refreshes itself. And one of the basic approach I think people choose, and that was the first thing we could think about when we wanted to provide such an experience, was that let's do some calls in the background, so user doesn't see them, but then we're gonna just ask the API from time to time to see if there are any updates. And that's actually something that is called HTTP polling. But I'm gonna explain it using a Shrek case, because I think many people know Shrek. It would be a shocker for me if somebody doesn't know Shrek. It's like not knowing Lion King. It's like basics. Come on, everybody has to watch it one day. So there's I'm not sure if it's episode 2 or 3. There's a scene where Shrek and Fiona, they travel to far away. And Donkey, he's pretty annoying there at the back seat, because he's just like a kid, right? So he's bored by the travel, and he's asking Shrek over and over, like, "Are we there yet? Are we there yet? Are we there yet?" Um, so it's pretty funny for me. I remember we were laughing a lot, and it's funny if it's in a movie, but in real life, I mean, nobody wants to disturb the server and ask for updates every couple of seconds. Now imagine this left side of the picture, um, where you have a client and the server. So basically, whenever you want to have updates from the server, you're opening a new connection to the server. That's how HTTP works. So you just open a connection, ask for updates, get the response, and do something in the UI. And you do it over and over. And there are different ways of doing it. You do it like in a short pulling, where you can do it quite often, like every 1-2 seconds, or long pulling, where the period can be much longer. Depends on your use case. But I mean, what's the point? And then that's where we learned about WebSocket. So WebSocket gives you this solution that you can just establish one connection, long-living connection, and then through which there's a stream of data floating, and it's bi-directional. So the cool stuff is that you can just talk to the server whenever you want and get replies from the server wherever you want. So it's pretty cool, pretty nifty. And the coolest stuff is that you don't have to send a message every second to the server. It should work in the way that you just connect to a given socket, a given channel, and that will always provide you messages. We'll send you a messages with the latest information about the status of a travel to far away, for example. So you instead of asking all the time, you just say, okay, send me updates, and then server depends on the settings. It's every second, or maybe only when change happens. Is sending a message to the client with the latest information, and it's much nicer solution, because for me it many times happened that I saw some UI. Somebody told me it's like super nice UI. It's refreshing the view without the browser refresh. But then when you go to the developers console in the browser, in the network tab, you can see like a new request, HTTP request going out from the client to the server. Not cool. And with WebSocket, that's not the case, and it works pretty well. Now, just going back to what I said about how old it is, because over time, also some other solution showed up. And just give me a second, because I have problems with mic. Oh, thanks, Sergio. So it's Shrek 2. And I hear the noise is coming in, so I have to restart the mic. Just a sec. Okay, back in game. So there are other solutions like between 2011 and 2020, 21. For example, HTTP2 showed up. And as far as I know, there are some there's a movement to maybe consume it and use it for WebSocket as a replacement for WebSocket. There's also this Mercure protocol, and if you want to learn more about Mercure, it's actually a very interesting project. The creator of the protocol was actually a guest on our AsyncAPI online conference last year, and talked about it a bit. So I'm gonna send you. So I'm gonna send you a link. So you can do Mercure. Like in my previous project, before I started working like full time on AsyncAPI, we had, for example, GraphQL API, and we still wanted to have this like real time refresh of the web, of the view of the user. And because we were using GraphQL, then of course we're using GraphQL subscription. So there are many different solutions, but the thing is that WebSocket it's here for very long, and there's a lot of implementations already. So like 7 years ago, I remember like we were always struggling that there was not much support. When Cloud Foundry showed up as a platform, as a cloud platform, at the beginning the WebSocket was not supported. It was actually a problem, and that was a time when we were doing this project as SAP, what I told you. And Kubernetes, as far as I remember, the also at the beginning, though, the ingresses, they were not supporting WebSocket. So yeah, but now it's time that I think it became standard, really. And what I mean by standard is that what I've learned, because as I told you, like my experience was I'm doing front end. I have a client where I want to get always the latest information from the server. So that's where I'm gonna use WebSocket. And that was always I was biased by this, by my experience, and I was always thinking like WebSocket only for the browser. But what I noticed recently is that actually WebSocket is adapted a lot in in a software where you need to provide up-to-date data on a highly available on a huge scale, like in the real time. And it's like really, I think that, I mean, at least I saw three different, like when I was exploring, yeah, three different WebSocket APIs for cryptocurrency trading solutions. So it looks like, for example, WebSocket API became a standard there to provide like real-time stream of information from the server that can be consumed by the client and by the server. And I see that Sergio also mentioned in the chat something called server send events. And yes, that's also a solution here, but I don't want to talk about it mainly because it's it's mainly about WebSocket, right? So let's not go into the different alternatives. Not this time, not today. So yeah, now Async API, and I hope that you. I mean, really, my assumption is that you already know a bit about Async API. That's why you're watching this stream, because you probably learned about it from some of our social channels. I can only like just summarize that what Async API can give you. It's first of all, of course, it's a specification. So specifications should be used for documentation, right? And that's how people use them in many cases. I'm super interested now, like a small digression, but it would be nice to see some kind of research, some results where people say what they use a spec for. Is it just docs or something more? So I personally think if somebody is already using some specification and using it only to generate docs, it's it seems to be, from my point of view, a waste of time. Even though you can, of course, generate nice docs out of it, it's really sad that to not reuse this the spec for other purposes, because in the end, the goal of the specs is to enable user to describe something in a machine readable way. So if machine that generates docs can read the spec in a nice way and generate HTML, for example, or something different, or Markdown, why not use machine for some other purposes, like, for example, validation of incoming and outgoing messages from the server in a runtime when your application is actually running on production. So you don't have to implement the validation on your own. You can just have some library that can validate those messages basing on the contents of the Async API document. Because in Async API, one of the things that you provide is the schema of your messages. So there are many different use cases, code generation, etc. So that's why that's why you have to look into Async API, and also because I don't think you have an alternative here, especially not in Open API, because Open API can't be used with WebSocket. Now, when I was doing the research, I already told you about this cryptocurrency trading. So I noticed I found Kraken API, Gemini API, Sexio, and even like the last one is Polygon. So yeah, as you can see, I really believe WebSocket is not going anywhere if there's such a huge adoption now in the cryptocurrency, which is like super trendy now. So just before I continue, I saw one question, actually one comment from Rodrigo about saying a bit vendor locking. So if you want me to somehow refer to your comment, you need to provide some more explanation. I don't recall when you added the comment, so I'm not sure what you mean by vendor locking. Because I don't think it's about WebSocket that it's vendor locking. Okay. So back into game. So today, again, I'm just gonna repeat. I'm gonna work on the AsyncAPI document for Kraken, and that's what is also described in my blog posts. But I'm also gonna touch Gemini because I also created an AsyncAPI document for them a few days ago. But yeah, WebSocket. So first, maybe let's play a bit with the WebSocket API to fully understand how it works. And there are different clients, of course. My favorite seems to be for now WebSocket, which is like designed to work with WebSocket. You can think about it as a curl for WebSocket, I think. So I have it installed already, and yeah, like look how easy it is. So Kraken, the cool stuff about those cryptocurrency trading companies is that they provide a lot of data without any need to be authorized. So it's pretty cool and pretty nifty to yeah, to play with those APIs without much of the struggle. So yeah, let's go to the Visual Studio Code. Let's make it large. Okay, I think it's large enough. Give me a second. I'm gonna try to hide. Forgot to hide the additional information in the terminal. Just a sec. Okay. So now, yeah, let's just make sure I have WebSocket. WebSocket, WebSocket, sorry. Yeah, WebSocket is here. So yeah, let's paste the command. So what I'm doing here is I'm using WebSocket to actually call WebSocket API from Kraken, and I'm connecting to it on using WebSocket protocol. But WSS means like with HTTP, you have HTTP and HTTPS. The same with WebSocket WS or WSS, which means that WSS is encrypted. So as you can see, it works. So connection got established with the API. Now let me send a first message. So remember, WebSocket bidirectional. I from the client can also talk to the server. So let me sync ping, and I got Pong. How cool is that? At least for me, it's cool. But I'm still a kid. Now I can also subscribe to some specific messages. But now bear with me. What does it mean subscribe? So the thing is that, like, in the past, again, looking back on my experience, was that you, when you were thinking about, okay, before I jump, so Rodrigo specified it was about Mercure. So thanks, Rodrigo. Hey, Arin. So looking on my past experience, because I needed WebSocket, we needed WebSocket for front end. So yeah, we were usually thinking about WebSocket channels that you need for a given view. So when I had a view of, I don't remember what it was, like projects, then I was only expecting projects to be sent to me by the server. So I had like endpoints configured in the way that I just needed to connect to a given socket, and the messages were sent to me immediately without any additional struggle, which was pretty nifty. But you need to know that WebSocket can also be used with sub protocols. And now that's not the point, again, of this live stream to talk much about it and explain technicalities here. But like, look at this API of Kraken. So normally I would just, what I would expect that I connect to, just maybe let's disconnect. Let's say I connect to some currency, and okay, now it's probably stupid and doesn't make sense much. So sorry if it's confusing for you, but let's say what you see here is that I'm using query not query. I'm query parameters would be here, but I can connect to a given endpoint with just currency updates and specify the name of the currency, which is PLN, which is Polish currency. And then after connecting, I would expect a stream of data, most up to date. But yeah, with the recently, I noticed many people use sub protocols with WebSocket. So WebSocket is just to enable you this connection and this bidirectional way of working. But internally, those messages follow a sub protocol. You just agree on some sub protocol that defines rules how you can, through one connection, subscribe to different messages and receive them from the server. So that's why, for example, when you can see here, I just pasted an example of how it works, for example, to get ticker updates from the server. Now, what ticker is, I have no idea. So the one problem I noticed when I was exploring those cryptocurrency APIs is that I probably would have to spend more time on actually understanding the subject of cryptocurrency, because there was a lot of I think industry wording that was pretty hard for me to understand. But I have some ideas, like I don't even, so I'm not a Bitcoiner and cryptocurrency at all. So I'm probably an ignorant, but XBT, I guess that stands for Bitcoin or not. But USD, of course, like who doesn't know USD or EUR? But yeah, anyway, go back to the topic. So I'm sending from the client a message to subscribe. Oh wait, I was not active for too long again. I'm sending a message that I want to subscribe my client to ticker updates for this from that currency to this one and that to this one. And as you can see, I'm getting a stream of messages with most up-to-date information about the prices. And from time to time, I got another event, which is a heartbeat to let me know that I still have the connection with the WebSocket API. So as you can see, the stream is going, but it's following some internal protocol that explains the subscription model. That is not part of WebSocket. So yeah, I hope that this stuff is clear. Now let us now go to the last section, which is creating the AsyncAPI document. So what I'm gonna do is let's try. I had no good idea how we can. So as I said, I already have Kraken WebSocket API created for Kraken. I'm gonna shamefully copy it over, and then we're just gonna go through it. And I'm gonna use AsyncAPI Playground to show it, like, yeah, to render this machine readable format in a nice way, using one of our tools. But side by side, let me show you. So we have pretty nice picture that shows the structure. Yeah, I think we can probably use that. So give me a sec to arrange the views. Let's see how it's going to look like. Okay. Async API. Okay, so first of all, you can see that we have even an article that compares Async API to Open API, because we got, I mean, Fran, when thinking about the Async API, he got inspired by Open API. But yeah, we need now this picture. Bear with me. Oh, it's not an image. That's interesting. Okay, un momento, per favor. Okay, let's try maybe this way. Let's open the image, maybe. Oh gosh. Okay, now again. Okay, I think now it somehow looks better, but I think I have to move it to the right, to the left, so it's next to the content. But I think it's gonna be nice to explain this way. Let's see. So yeah, on the left you can see a structure of of the um, Async API document, how it should look like, how the specs looks like. On the right hand side, you can see a playground with the content of the Async API document for WebSocket API, for Kraken, and how how it renders as a documentation. And just to give you an idea how how was I was able to create it, because I found a official Kraken API documentation, which basically when I look at it, I think they are using Async API, older version of Async API, because the UI, it looks like it's generated with the old documentation generator. But I might be wrong, of course, which is fine. But yeah, anyway, I found official docs, and just by trying to consume docs, understand docs, I wanted to reflect them in the Async API document. I was not able to do everything fully because some endpoints are required to connect through some secure connection. So I didn't go that far with the topic. But yeah, so looking on this preview of how the document should look like. So you have few core parts like info, where you specify basic information about your application. You've got servers, where you specify the way to connect to the application. So the host and the security related to this connection. Now there are channels that where you specify this like a connection points with the server with your application, where you can consume or publish, on which channel you can consume messages and publish messages, and what kind of messages. So it's let's say channel is the meat, right? It's the central point here. Then it's ID, but yeah, that's not so important to tackle in external docs. Tags, of course, it's useful for rendering of documentation, for example, or to provide more documentation references. And then last point is components. So it's a section where you can put some information that is duplicated across the document. So you can put them there to reuse. So for example, you have a message, you have few messages, and all of them, for example, contain some specific object in the payload, or not an object, it's just some ID or something. So instead of repeating the same ID in all the payloads, like let's say you have 20 messages in 20 payloads, you just provide schema for this ID once in the components, and then you can refer to this schema from other schemas. So that's the point about components. Now, info. So in case of Kraken API, that was super super easy to do. Just copy paste from the official docs. So what you can do with info, you provide the title, the name of the API, the version of the API, and some description. You can do it in Markdown as I did it here. But the most important is what you should notice when I talk about Async API. I always say like your application, the application that you describe. It's super important to remember that whenever you write Async API document, you write it for your application, and you write it for your application in the way so that when client reads it, the client knows what to do with the API. It's super important. So you don't describe with Async API document what the server does, but what the user, what the client can do with your application. Okay, that's super crucial. Now, next part is servers, right? So what I said is the way how you can connect with the API on what host was the security. Now, in case of Kraken, they have like 4 different servers, and they document them all on one view. So you have like secure, like completely open server that does not require any authentication. You've got a server that requires authentication, and you also have beta servers with some beta functionality. So I completely ignored those, didn't put them in the document, because it's super specific to your use cases how you provide beta solutions. If you really provide them as separate servers, or rather hidden behind some feature flags, so it's not for me to judge how they do it. For sure, you can't just generate different code for the official endpoint, the official server, and then some beta server with some different solutions, different features. So I've put public and private. Now the private stuff, that was a problem for me. I could not figure out using their documentation how they do the security of the server. So basically, I had no way to describe. I did know. I mean, there is a way how to describe. You can use AsyncAPI to describe the security of the server. I just had no idea um, how I can do it for Kraken, because I had no idea how Kraken security works. That was not clear for me. What's the standard used there? But just for the record, um, security is of course possible with Async API. So you can specify more than just URL and the protocol. You can also have variables in the URL, but most important is that you can provide some references information about the security. So yeah, now why I choose to provide public and private here in one document, if in the end they provide different functionalities, and that's how it is with Kraken. So some information that you'd like to read from the server is not available on the public server. It's only on the private server, where you need to authenticate to get your probably some private information. Now, it might be a problem for code generation, but not necessarily. So again, like technically, it's possible that you have one server with 2 different host aliases. So one server can be accessed by people via the ws.kraken.com, and the other can go to the same server. The other client can go to the same server using the private connection. That's technically possible, so you can still do the code generation. But to make it super simple, I decided that I'm doing this, let's say, mistake that I described at the beginning, and I spent time on learning spec only to create Async API document to generate docs, which again, it's not the, you should use it for more things. But so I said, okay, I just want to generate docs. So that's why, from my perspective, it's better to just describe those 2 servers in one Async API document, to have one view, information in one view. But normally for code generation, I would consider splitting, like, because it sounds like it's most probably two different servers with two different entry points, maybe. So you'd like to describe them separately and separate the functionality description. Because with AsyncAPI, it's also possible. So we can, like, again, like this is just one document for Kraken, but I could have two documents, one for public, one for private. In the public document that exposes the public server, I could describe just the things that are only available on the public. Now with the private, with the document for the private server, of the private part of the API, I could describe only the private stuff and describe how to authenticate, etc. Now, they both have some messages in common, like ping pong, heartbeat, and it's not a problem. You don't have to duplicate them in those two documents. You can have common parts because, like with Async API, we take advantage of $ref property, so you can reference external files from URL, from local drive, from inside the document, or to a specific part of the document. So you can reuse things. So most probably on production, when I would really work on Kraken API, Async API document, I would strongly consider writing two. So as you can see, it's always depends. Always depends a lot on the architecture as well. But yeah, channels. Let's maybe go to Kraken docs. So as you can see in the documentation, like there are those general messages, and there are these servers, and actually there are no channels, like there are no endpoints on the server. You might recall here when I was connecting to the Kraken API, I just put the host. There's nothing like test endpoint or something. Doesn't matter what I put there. It's totally irrelevant. There's just one single connection point, and as I said, there's probably some sub protocol they agreed upon how the subscription to given messages work. Now, going back to Async API document, this means you have an application that has a single channel, and if it doesn't have a name, like in case of the server endpoints, paths, whatever, there's nothing. Like you connect to the server on the root. That's just how you describe the channel. Just put slash. That's it. As simple as that. But if I would have like a test, then I would put test. Right. Now, publish subscribe operations, they are they have different meaning. And you remember when I said, like, keep in mind that we describe an application from a client, from the user perspective, what the user can do with the API. So yeah, then publish means that the user, the client, can publish to this API, send messages. Okay, and subscribe means it can subscribe, meaning it can just receive messages from a given channel. So publish, subscribe, you can translate into publish is like you can send messages. Subscribe means you can receive messages, you can consume messages, whatever. And in case of Kraken, as you could see, on one connection, on one channel, I could send different messages and receive different messages. So I could send ping to receive pong, but I was also after establishing a subscription. I was also not getting only subscription status, but also the heartbeat. So the heartbeat message. So it means that your published channel has many different messages, and then you use a keyword called one of. So in a channel, on a publish operation, you specify that on this channel, uh, client, as a client, you can send to the server uh, three different messages: ping, subscribe, and unsubscribe. And you can receive four different messages, which is pong, heartbeat, system status, and subscription status. Now, what is operation ID? That is here. Now, I did not. I've put it in this document, although I think it's not really needed, especially that operation ID is mainly for code generation. Because when I was creating this document, I was not thinking about code generation. This operation ID is not very much needed, because you use it like in code generation when you want to have some defined names of functions, of handlers that will consume message and that will process messages. Um, but it's because it's here. It's nice to go again into explanation of publish subscribe. So me again as a user, as a client of the API, I can publish to the API, but it means that when you generate code for your server for Kraken WebSocket API, when you will generate code and you will to generate code, you're gonna read AsyncAPI document. Publish means that you are receiving messages. So you have to process the incoming messages. So you basically have to, in your API, provide a logic that consumes ping, subscribe, and unsubscribe. And if it subscribe operation and user can, it means that user can receive messages. It means you have to, on your server, have a logic that when there's a subscribe operation, you have to send pong, you have to send heartbeat on given conditions, of course. So that's super important. It's not that confusing, and it makes sense with WebSocket when you have client and a server. Like with OpenAPI and REST API, you have client and a server. But if you use AsyncAPI for architectures where the client does not connect directly to the server, but there's a broker, a message broker in the middle, that's highly confusing. That's super confusing because you have many, like a application can be a client and a server. It can consume messages from a broker and send some additional messages to the broker. So it's super confusing. I don't want to go into this. I definitely recommend you to subscribe to our blog. We have RSS feed, because probably today or tomorrow we're gonna publish a blog post from Nick that actually explains those pub/sub semantics in a nice way. So yeah, so we have what we have. So we have info, right? We have servers. We have channel item, which is the slash. We've got operation, some summary, and messages. But here you can see those refs that I mentioned already. It's because it's much cleaner to read such a document when you don't put messages directly in the channel, but reference them from the components. So we're gonna jump now to the component section. So messages, the ping message. What I can do with this spec, I can of course provide some short summary, some description, which is very important. some reference to the payload, so to the schema. And now let's talk about the schema. So AsyncAPI allows you to provide information about the payload of the message using different schema formats. So if you use JSON schema, then it's super easy for you because you can just put it directly in the AsyncAPI document, because AsyncAPI schema is a subset of JSON schema. So you can put JSON schemas if you have them already. What if you, for example, like probably not in the WebSocket, but in many Kafka users, they use Avro schema to describe messages. And that's totally fine. It's supported. You can put Avro schema payload description into AsyncAPI document, or you can reuse the schema information about the Open API document. So if you have already REST API with some schemas already defined, and you want to reuse, because the messages will look the same, you want to reuse those schemas in your application where that only talks through a like event-driven interface, so talks to some broker or WebSocket endpoint, then you can reuse those schemas between those two documents. So it's you can connect Open API and AsyncAPI document this way inside your AsyncAPI document. But yeah, let's it's JSON here, so let's go to ping schema. Scrolling slowly so you're not getting lost. Okay, so we can see ping. So it's an object, and it has two properties, where event is the required one, and it's always ping, and there's always a request ID. You remember when I told you about that when you have some ID that is the same across all the messages, you can reuse. So again, you can see, oh, wait, sorry. So we can see that even inside components, inside schema, inside components, you can refer to different schemas in the component. So it's, yeah, for reusability, it's super nifty. Super nifty. But yeah, let's go back to the message. That's easy, right? So describing the message payload. Now, what the heck is that, right? What is X response? So Async API allows you to provide extensions. So basically, it means that you can add some extra information to Async API document if it's not available yet at Async API spec. Why? Event-driven architectures, it's a really complex beast. You have many different paradigms there. You have many different protocols there. It's not as easy as with Open API and REST API, because Open API is for REST API, just one protocol. That's simple. With event-driven architectures, there's just like huge amount of protocols, many different protocols. And Async API aims to support all of them, to be protocol agnostic. So if you have some extra information about some protocol, you can put them in the document using bindings. But it's, wait, my mic again. So the idea is that with extensions, you can not wait for, you don't have to wait for the spec until it supports something. You can already start using something, like describe something extra in your document. And a small information here. So whenever you want to add something to the spec, like we always encourage, like try extensions first, share the extension with others, and see how it goes. And we have have extensions catalog, Async API, or a place where you can share your extensions. We're gonna put some much more effort into this. But the idea is that don't just create some custom extensions for your own. What we want to encourage here is that you should create extensions, share it with others. We're gonna see how many people reuse it, and if like the adoption of the extension grows, then it means like it's a perfect candidate to get into the spec. So that's basically the idea for the extensions that you could follow. But yeah, let's focus on this X response. So something that you don't need, I don't think you need it with when you have message broker somewhere in the middle, because with message broker you just send a message to the broker and you don't care what's happening next, unless you use nuts. Then that's different. So in nuts, but not only in nuts, in WebSocket, you want to know what's the response when you send a given message. So how do I know that after sending to the server ping message, I'm going to receive a pong message? Because here what I can see now, I just know that I can publish multiple different messages and I can subscribe to many different messages. But there's no way to say, okay, when I say ping, I send ping, I get pong. When I send subscribe, I'm gonna get heartbeat and a subscription status. And that's where references can help. So I just followed the one of the topics we have. Actually, I recommend you, if you're interested with this request reply pattern in event-driven architectures. There's still ongoing long discussion how to best support it in the spec. I'm gonna paste a link for you so you don't have to. It's easier to access. So you can see this discussion, like how to express with AsyncAPI document that on ping, I'm gonna get pong. The advantage of extensions is that you can explore. You don't have to wait for the spec to evolve. You can actually see how it's going to work for you. And then it's even better for us. I mean, you're going to suggest us a change in the spec by just providing examples of what extension you got, how it works for you, and what are the advantages of a given solution. So yeah, that's how in this document I at the moment express this reference, right? So at when I send this message, in response I got another message. The cool stuff is, I hope so actually, that we updated the playground already. Yeah, we rendered those extensions in the playground. So if I use reference to existing message, of course now it's not the nicest because it's a response. It's a reference, some unknown property. So we dump entire subscription status message object. Oh wait, it's not the. We should check the pong. Sorry, where's the ping? Yeah, pong. So we show the entire object representing pong message, but in a few days there's going to be an update in the playground, thanks to Maciek, and he actually is doing some magic here that makes it much nicer. So it's actually rendering the payload only. Super cool. Anyways, so Async API, it's not perfect. It has its limits, but it doesn't mean it can't be made better. I'm not gonna say let's make Async API great again. So I'm just gonna refer something much more important. So the Async API specification you can find in this repo. And you need to know it's not just like me, Fran, or some few other folks running the project. Since 1.5 months, we're part of Linux Foundation. We have an open governance model. So we want to work on the spec on next versions with the community. We have a clear contributing guide, pretty fresh, that we copied from GraphQL that describes well how to get changes into the spec. So I'm gonna send it to you also in the chat. Most important is I don't think we made a decision yet, but I haven't seen any comments in the issue. So it looks like we're releasing in June a 2.1 version of the spec, and the changes I know that are already proposed, they're not coming from actually maintainers of Async API. It's coming from the community. So to summarize, we're not perfect. We want to get better. Just join and contribute. We're super friendly. At least I think so. My kids like me, so my dog likes me a lot as well. So just use extensions. Give us a heads up. Provide issues. Describe your use cases. What is missing in your case? What's the use case for you? Show how you use it with your extensions, and then let us improve the spec. But at least the cool stuff is that you can always find a kind of workaround for that. Okay, so we have messages like headers not needed for WebSocket, payload. Now, in the articles about Kraken, you can find a pretty nice example. Where was it? Yeah. So in the in my article, I was going through every schema one by one, adding it, and there was one super complex schema. I mean, for me, whenever one of or any of is used, it means it's super complex. So I think it's pretty nice nice exercise to go through at least the sections, schemas, complexity, see a different ways how you with JSON schema you can express the structure of your messages, and the trade-offs sometimes you have to take, because not always all the features of JSON schema are supported. For example, in Async API tooling, not all the cases are yet supported. So sometimes you have to make trade-offs and choose different ways to express the same thing, which in the end it's fine as long as it's technically not meaning something different. What else we can talk about Kraken here? Let me just refresh. So I talked to you about the limits. Client server interface, the security stuff I told you about, sometimes that you have to split your documents I told you about, extensions. Yeah, I think that's it if it comes to Kraken API. So let's close these ones, these two. Okay, so now something extra. You are what? Sorry, Sergio. I have really short memory, so I said something 1 minute ago, but I don't remember what it was. You have to tell me. You are what? So in the meantime, API is Gemini. Again, cryptocurrency. And by the way, uh, I was not. This stream is not supported by cryptocurrency um, companies, but I like them because they expose their APIs without authentication, which is super cool for learning. Love you guys. So they have a public market data API. Oh, and you see, that's give me a second. Like, see this private, public, different APIs. So again, you can see there are different ways of expressing here. So in Kraken, it says it's like one API. It's marketed as one API with public and private servers. Here, it's clear that it's private API and public API, like two different APIs. Okay, so it's super. I prefer Gemini way because it's cleaner, in my opinion. I mean, I have a lot of background in technical writing and content architecture, and I know that from user perspective, it makes you focused on given functionality only. You're not thrown into everything at the same time. But yeah, there are different schools for that. So Gemini, I I looked at Gemini because they their V1 version of the API is totally different than the Kraken, and their V2 version of the API seems like following the same pattern as Kraken API took. So a single connection point and some sub protocol used internally that defines how you can subscribe or unsubscribe for given messages. But V1 is like totally opposite, like something that I'm used to from my previous experience with the API. So this stuff is super different here. So let me go here. So we talked about Kraken. Yes, I have a AsyncAPI document for Shrek app, but that's in different on a different blog, different stream. But I have Gemini. So let's take this Gemini and put it in our playground. Okay, so what's so different in case of Gemini and AsyncAPI document? So info, I don't think I have to go much into details. So it's like basic information about the Gemini market data WebSocket API. Some external documentation provided. Server. Oh, that's a leftover from my Shrek app. I have to fix my PR. Okay, I'm gonna do it after the live stream. Ah, that's good. Okay, channels, the most important channels. We've got one channel. We got one channel like in case of Kraken, but we could have more. In the channel, you can see something extra. It's not just a slash. It's not just you can't access the server data on a root. You actually access it on a given endpoint, and you have even some dynamic properties here, parameters here. So depending on a given parameter, you're getting different answers from the server. So let's first let's just trigger the API first. So let's connect with WebSocket to Gemini v1 market data. Now, what the documentation generated tells me that I can provide a symbol, which is a parameter that is an enum of different versions. So let's specify different symbol. It's, the definition of the symbol, it's again something much more complicated, but yeah, you can see it's somehow referring the cryptocurrency name and the real current, like real, like crypto is not real, but yeah, like the normal, usual, whatever old currency name. Now, as you can see, I have also query parameters, and I don't have them here in the name of the channel because query parameters, that's something super specific only to REST API or WebSocket. It's not available on any other protocols, at least not the ones that I know. So that means it's something super specific to one protocol, which is WebSocket. And here now you're going to see something in AsyncAPI document that you could not see in Kraken, because in Kraken there were no protocol like WebSocket specific information. But here you see a new key in the document, which is called bindings. And it's a way in AsyncAPI to provide custom protocol information into AsyncAPI document. So and it makes the AsyncAPI document a protocol agnostic. So we can, as you can see, using basic features of the AsyncAPI, I could describe Kraken API, but sometimes you need some specific protocol information like query parameters that you have to provide inside the bindings. And we have a list of all the bindings for all the protocols also maintained by the AsyncAPI initiative. I seriously have to explore what's happening with my mic. So as you can see, there are many on the list, but the list is not closed. So if there's some protocol you don't see on the list and you want to contribute the specification of the binding for a given protocol, we're all yours. Just join and we're gonna give you direction how to do it. But yeah, WebSocket binding. It describes what kind of additional information specific for WebSocket you can provide on a channel level. And that's what I'm using here in the Gemini document. So I specify the binding version, of course, that I'm using, and there's this query property, which should be a schema that describes different query parameters that can be passed in the in the path. So I can specify, for example, heartbeat, that I don't want to only get information about the currency, but also want to have regularly, every 5 seconds, heartbeat information that I can consume and make sure that I have connection with the server, right? But there are many different query parameters here. So basing on this information, I know what symbol I have to use. And I also know what specific binding information, like channel specific information I have. Again, now it doesn't look perfect, but yeah, few days, it's gonna be lovely. So I know what query parameters I have. So let's go back to the terminal. So I have Gemini, market data, the symbol, and the heartbeat set to true. Okay, and yeah, as you can see, a stream of data is coming in. And from time to time, let me just stop it. And as you can see, from time to time, I get a heartbeat. What else super cool to notice here? So we have this parameters that we can have in the path to the channel. We have protocol specific information here about WebSocket. So we know what query parameters we can use when connecting. And we know that we're gonna, as a client, we can only receive information from the server. So there's no way to send the messages that I'm sending to this server, to Gemini API. It's not going to be consumed and used at all. And there's just one message that I can receive. So it's not one off, as you remember from Kraken. It's just one message that I'm gonna always get from the API on a given of a given structure. So that's something super natural for me. As I said, like from the front end experience I had in the past, that's what I would expect at first, right? Some clear endpoint I connect to with some query parameters, and then I get a stream of data, and that's it. I don't have to learn any sub protocol or whatever how to get access to some more messages. But that was for front end, and I believe they are not in cryptocurrency. They're moving away from this approach, not just because they like to do some new stuff. If Gemini had the old way in V1 and jumped into V2, following the pattern from Kraken, I think it basically because makes sense, because you don't consume this information only now in the front end just to build some nice UI or mobile app. I bet that most of the consumers of this data are bots, some servers that can actually, it's better for them and much more scalable to interact with the API through some sub protocol than just establishing connection on different paths. Because yeah, bot is not UI. You don't have different views in bots. That's my assumption, though. I haven't ever talked to any developer or architect from cryptocurrency solutions. Now, last but not least, is the payload of the message. Again, I'm not gonna go now into details again of the schema. It's super specific on the use case. This schema was also a bit complicated, so I'm using all of and one of here. Because the structure of the message can be different depending on the query parameters that you pass. But I think the most important here is this part. Examples, which are super important. And I'd like to explicitly encourage you that whenever you provide your AsyncAPI document and you provide information about the payload of your message, you should still explicitly provide nice examples. Don't count on any example generators, to do it for you, because they will never do it better than if you would add them manually. And the advantage of adding multiple examples manually is that you can, for example, on a nice scale, use tools like Microx, which is super cool, enables testing and other stuff by consuming AsyncAPI and enabling you with nice testing and mocking solutions. And of course, if you do some testing and mocking, you don't want to mock with some generated data. It's much better and much easier to test and consume if your examples are nicely structured. So always provide nice examples. That's what Uncle Lukasz says. Now that's it if it comes to Gemini. That's it if it comes to Gemini. And I think we played with Gemini API. You see query parameters, the parameters in the path. I showed that all to you. What other APIs maybe? I learned about Polygon.io, thanks to Keen. And let's see if maybe real time we can try to write something for them. I think we still have a few minutes. By the way, I mean, you're super silent in the comment section. If you have some questions, just feel free to shoot them, unless I'm so good in explaining things that you don't need to ask any questions, which sounds good. So let's see if I will not read about authenticating. Let's see if I can just get anything from them. Oh, so as any other cryptocurrency solution, at least I think they're cryptocurrency. Real-time stock, Forex, crypto, yeah. So I got connected, and it already tells me that, again, it's a bit different API than the Kraken and Gemini, because you can see that their server also has a dedicated stocks path, which means that when I would be documenting it, let's go to Playground. You remember in the channels for Gemini, I had path where I can connect and a custom parameter. In case of Kraken, I had just this because you could connect to the root. But in case of Polygon, I would do this, right? So just to make it clear, I would do this to describe the server, the protocol, and then the channel would be stock, right? But then if it comes to, okay, they don't provide anything public. I have to authenticate. I don't want, even though it's free, I don't want to register again somewhere. Seriously, when I will try to subscribe, it's not going to work. Timeout. Okay, let's try again. I'm connected, and let's try to subscribe. Not cool, guys. Not cool, Polygon. So I'm not going to be able to actually play with them. If I'm not going to be able to play with them, I don't want to go into it. But anyway, you can see it's the same pattern here. So they have some sub protocol they use to so you connect just to one channel. There are no parameters, no query parameters. You just connect to the server, and you have a schema, some protocol that you have to follow to send message that is enabling you to subscribe to some specific information. and that's it. So it's nothing different from than I described in the for Kraken and Gemini. So okay, I think it's 1 hour 40 minutes. That's long, super long. So I don't see any questions in the comment. I'm super interested what you think about this way of sharing information, especially if you don't watch, don't read articles. Maybe it's gonna be much more interesting to watch the video again. So in the chat, I've pasted links to all the articles that I used in this live stream. So you judge if it's better to read 2 articles in about 40 minutes, then watch the recording of this live stream that is like 1 hour 40 minutes, which is longer. But again, you have free hands, free eyes. You can do something and then just listen to my lovely voice. I think that would be it. So just summarize what we talked about today was AsyncAPI and WebSocket, how you can use AsyncAPI to describe your WebSocket API. Also, I did some intro about WebSocket in general. Why would you use it with AsyncAPI? And we covered a few different ways of using WebSocket with AsyncAPI. And I just wanted to shout out to those cryptocurrency solutions that provide their API without any authentication. Super cool that you do it, because then we can use it as a learning platform for others. And in exchange, you get some ideas how you could use Async API, right? So also shout out to Kraken and Gemini. At Async API, we're super curious if the market of cryptocurrency and all those solutions already adapted Async API or plans to adopt it. As you can see, it's not that difficult. And I mean, I'm super happy to help you out. Reach out to us. And last but not least, and how to best reach out to us? One of the channels, Slack. So join our workspace. We're pretty friendly there and helpful. Yeah, that's enough, I think. Thanks a lot. Let me just now stop sharing. Thanks a lot, and hear you next time. I was thinking about making a live stream that explains how to use our Node.js template to generate Node.js application, but not for WebSocket, but purely for a solution where there's a message broker somewhere in the middle. So I explain not the Async API in general, but explain how to actually use the template, where to put your code, how it works. But yeah, and if it comes to code generation about WebSocket, just a kind reminder again, there's this EDA summit on 19th of May, and I'm going to present there and explain how you can design your Async WebSocket API with Async API and then generate code for Shrek application. So yeah, thanks a lot, and see you next time.